So it turns out there's a bunch of container-like classes in the C++ standard library that are not strictly part of the standard template library, but they have certain things in common, certain characteristics that are kind of like what you find in the standard template library. And of course, the one that's most obviously like this is the C++ string class, which is a very powerful and popular class that lets you do string operations. And even though it's not strictly part of STL, it has some properties that are reminiscent of STL. And for example, it has the ability to have iterators, and you can also use some of the STL algorithms and functors and so on strings. And so as a result, it behaves a bit like an STL container, a bit like an STL sequential container. So let's take a look at an example to make this more clear. So down here we have a string called my letters, and we give it all the letters in the alphabet. And then we go ahead and we're going to do this. We go ahead and go through every element in my letters, and we're going to print them out, and we're going to keep a running count that keeps track of how many we've printed out. All right, so that's what we're going to do. That's pretty straightforward. You can see that then what we're going to do down here is we're going to do something similar to this, except we're going to use the iterator mechanisms. So we're going to say myletters.begin, and we're going to go through up to myletters.end, and every step along the way, we're going to go ahead and print out the contents using the iterator syntax. Now, if you look carefully, I think you can probably see this on your screen. My my program is complaining and saying, hey, why don't you use a range-based for loop instead? So you can see here that it really, really wants me to use this range-based for loop. Well, I already used a range-based for loop earlier to show how to print out the contents. So here I'm just showing the fact that you can, in fact, treat a string sort of like an STL sequential container. You don't have to do it that way. In fact, the compiler doesn't really want you to do it that way, but you can, and it does, in fact, have begin and iterators. So that's just a simple example to illustrate how this works. Let's see if we can run it. And in fact, as you can see, it prints out these characters. And this time, when we first print them out, we indicate which number the letter is. So A is 1, Z is 26, and so on and so forth. Okay, so that was one example of string. Let's now go ahead and take a look at another string example. And to some extent, I'm showing you some of these things because knowing about C++ strings is very useful, whether or not you're using STL. Now, most people are using STL with C++, but it's possible to write lots of C++ code that doesn't use STL that could still use strings. I should also point out, as we'll see in this example, that C++ strings are a bit different from Java strings. Java strings are so-called immutable objects. And one of the consequences of that is every time you do anything with a Java string, you're either reading its contents, like going to index location I and getting the character there, or you are creating a new string. For example, substring with Java strings will create you a new string altogether. You never end up modifying anything that's a string. Whereas C++ strings are not as draconian about this concept of immutability. And so that has pros and cons, but it's often more efficient to do it the way that C++ does it, depending on what you're trying to do, of course. So here's an example of creating STL strings. I guess I should say it's really C++ strings. And first we start out by making ourselves just a const char star string literal, pointer to a string literal. It says, say goodnight, Gracie. Then we go ahead and create ourselves a C++ string from the const char star string literal string pointer. And then we go ahead and make ourselves a new string where we just pass in a const char star string literal directly. Now we say goodnight, Gracie again. And you can also use the copy constructor as we do here. And of course, we could use the move operation. If we didn't care about string 2 anymore, we could use the move operation and just transfer its contents from string 2 to string 3. What we're going to do now is we're going to go ahead and create a substring by taking string 3 and going ahead and extracting from it a 9-character substring starting at the 4th location. So it's basically, I think, going to be good night. So that'll be string 4. And we could either do it that way, or we could use the substir operation to go ahead and explicitly extract that from string 3 and store it into string 5. And then we can go ahead and do a find operation looking for the word Gracie in string 2. If you recall, here's string 2, Gracie. And that'll return to us the location where that item was found. And then if that item was not the non-pos or the end pos, which is kind of like looking up something with a that returns an iterator and having it equal the end iterator. So if we get a match, then we go ahead and we erase things. We erase 6 characters starting at location 6, and then we go ahead and we insert at that location the name Irene. You can see that when we do erase and insert, it's actually updating the string itself. This is, again, distinct from Java, where you'd have to make a whole new string. And when we're done, we go ahead and print S2 after we've modified it. So I think it should say something like, say goodnight Irene instead of goodnight Gracie. And then we show how you can append a bunch of strings together by using the plus operation. So we're going to connect those together, concatenate them, then we print the results there. And notice how we're using the assignment operator here. So this, again, is illustrating the fact that you can do operations on existing strings and modify their state. And then we're going to do a match, which is going to look for the first instance of one of a number of characters. So it'll look for I or E. We're going to go look for the first match. And if we find that match, we're going to go ahead and print the character and print the position that it occurred at. So let's go ahead and run this code and see what we get. So you can see when we first do the print operation up here, we're going to go ahead and get rid of poor Gracie and replace Gracie with Irene, and then print that. So it'll say goodnight Irene. Then we go ahead and take string 2 and add a space at the end, and then add stir 4, and stir 4 said goodnight. And we got stir 4 by using the substir operation here in the constructor. So we took S3 and chopped out goodnight. And then down here, we go ahead and look for the first match of I or E, and we find the character I in Irene, and that's going to be at location 15 in the string. So this is just illustrating some cool common string operations. We have one more example of string, and then we'll be done with our string coverage. So this example just illustrates a whole bunch of things you can do with a C++ string. So we're going to go ahead and make a string with just a bunch of characters, basically A through G with a space between D and E. We're going to make another set of characters, X, Y, Z, I, J, K, just sort of nonsensical gobbledygook. We have an empty string here, and we're going to print out A and B, and then we're going to see whether or not C is empty, which of course it will be. Then we're going to go ahead and concatenate A and B and store it in C. That's, of course, using its assignment operation. And then we're going to go ahead and print out various metadata about the string. We're going to print out its length, its size, its capacity, and whether or not it's empty. And you'll see that these different values mean different things. And when I run the code, you'll see the difference between length and size and capacity. Capacity is how big the underlying buffer is, which actually may be larger than its length or its size, because strings try to anticipate the fact they could grow. And so when you allocate memory for them, they'll sometimes add a bit more on the assumption that you may be adding more elements to it. And that way you don't have to keep redoing allocations, or the string class doesn't have to keep reallocating the memory every time it's accessed. Down here, we go ahead and assign the contents of C into string D. This, of course, is not the assignment operator. This is the copy constructor. And then we go ahead and put some stuff into a new string F, print out its length. We append ZZZ at the end of F, print out its length. We make another string with ABC, 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 print it out. This is just demonstrating these features. And then finally, we go through here and do a couple more things. We do a replace at various locations, and we do a find, and then we do a find first not of. And so let's go ahead and run this code. And I probably won't walk through it all in great detail. You can always run it yourself to see exactly what all these things do. But I do want to show you a couple of interesting things. So for this particular implementation, and this is not always the case, if we were to run this with different versions of C++ library implementations, we would get different results. In this particular case, the length, the size, and the capacity are all the same. That's not always true. Some implementations will allocate some additional memory for capacity. And then you can see we just went through and made a bunch of text replacements and found a bunch of different kinds of things. So like I said, I'm not going to walk through all that code. It's a bit kind of boring, quite frankly, but it'll help you understand the operations that are available on strings. And believe me, there's a lot more where that came from. So strings have lots of different operations you can do on them. And it's a great example of a class that was designed by a committee, and it literally was. The string class in C++, in the C++ standard library, was in fact designed by the committee, and so it's got every imaginable method you could ever possibly want. And it's interesting to compare and contrast that with the standard template library, especially the early parts, the early containers like vector and set and map and deck and list and so on. They weren't designed by a committee. They were designed largely by Alex Stepanoff and Dave Musser and some other colleagues who were working at HP, or some of them were working at HP at the time. I think Dave was a professor. And those are much more well-crafted and concise and have all the nice properties of something that was really thought out very carefully and orthogonally, as opposed to just throwing every possible feature into the interface. Okay, so that's the overview of strings.